we're going to be using some experimental data to determine formulas of some covalent compounds. And so before we get into that, we need to distinguish two types of chemical formulas for molecular compounds. Molecular formulas is the type that we normally use. It tells you what is in one molecule. So technically it's kind of the correct one, the standard one. So if we consider this molecule here, the molecular formula would tell you what is in that. How many atoms of each element are in that. The empirical formula is it is the reduced version of that. It shows you the lowest whole number ratio. And so if we basically reduce this, we get like that. Why would we use an empirical formula? Because it's not really correct as far as showing what's in a molecule. The reason that we sometimes talk about that is sometimes experimentally that's all we know. We're identifying a compound and we know that lowest whole number ratio, and so we may use its empirical formula in that case. If we have enough experimental data, we may be able to go from the empirical to the molecular and figure that one out, and we will be practicing that. Notice that the molecular formula is always some integer times the empirical. So in this case, what is that N? It's a 2. So let's see how we can go between having a empirical formula, the lowest whole number ratio, and figuring out what the real molecular formula is. We're given some data here. MW is for molecular weight. That is the mass of one molecule, and it is in atomic mass units. But we can quickly see that that is the same thing as a molar mass, which is the mass of a mole, and it's in grams per mole. Anyway, just another way that could be said. So the compound's real molar mass is this, and that would include everything that's in one molecule. So what we can do is take the molar mass of the empirical formula and see what it would be. So add up the numbers on the periodic table. Okay, and then we know that the molecular formula is going to be some multiple of that. And so you can, the N that we say. So we can find the multiple by taking the total and divided by the empirical formula's molar mass. So in other words, we're going to do 42 divided by 14, and that gives us 3 for our factor. And so if we're going to take basically this CH2 and use the multiple of 3, we would have C3H6. So that is what tells us what is really in one molecule of this compound. So we know how to get from an empirical formula to the molecular formula of a compound, but how do we get the empirical formula? Well, we can get it from our percent composition, and these are the steps that you use. The first one is the kind of the trick, because percent composition is in mass, and formulas have subscripts that are in terms of numbers of particles. And so basically you have to have a way to get to mass from the percents and then to moles, which is number of particles. Then you have to massage the numbers to get to whole numbers, because we know that chemical formulas, the subscripts are whole numbers. And then we'll have an empirical formula. If we have a molar mass, we can get to our molecular formula.